Galvanic cells that involve the following pairs of half reactions are constructed. Write the net ionic equation and determine the standard cell potential for each galvanic cell. Let's start with standard cell potential. So if I go and use the table that belongs to standard reduction potential, I can find it for the first reaction. The ER is 1.51 volt, and for the second reaction we have ER 1.2 volt. Since the first one is greater than the second one, it means that the first reaction is going to be reduction and the second reaction is going to be oxidation, because this one is more stronger oxidizing agent comparing to this one. So I can say delta E R of cell equals to ER of cathode minus ER of anode. So that's the standard cell potential. That's gonna be 1.51 minus 1.2. That's gonna give me 0.31 volt. And after that, we need to, for writing net ionic equation, we need to arrange this one in such a way that the electrons cancel out. So I'm gonna write the first reaction as is, because that's reduction. It means that it gained electrons. But the second reaction, I'm gonna flip it. So it's gonna be 1 over 2 I2 plus 3 water gives us this, plus 6 hydrogen plus 5 electron. Now if you add these two reactions, these two cancel out. Water and water cancel out, and we have only one of them, because here we have 4, this one is 3, and then we have 6 hydrogen, 8 hydrogen, so it's going to be 2 hydrogen in this side. So when we add them, it's going to be MnO4 minus plus 1 over 2 iodine, 2 proton, IO3 minus plus Mn2 plus H2O. So that's the net ionic equation for these two half reactions.